If someone asks you how many numbers are between 1 and 3, what would be your answer? Well, believe me or not, the best answer for this question would be, what kind of number are you talking about? If they are talking about an integer, then the answer is 1, which is 2. But things get a little bit complicated if they are talking about real numbers. Real numbers are all numbers, including integers and fractions. More specifically, all rational and irrational numbers. If that's so, we can fit 1.5, 2, and 2.5 between 1 and 3. We can fit 1.25, 1.5, 2, 2.25, and 2.5 between 1 and 3. What I'm saying is that we can just keep decreasing our decimal point, and we will be able to fit more and more numbers between 1 and 3. To actually understand what is being said, I'm going to explain to you something that should blow your mind. Let's take two arbitrary real numbers, a and b, which are distinct. By arbitrary, I meant these two numbers can be any number. And by distinct, I meant they are not equal. Now, if we take the average of a and b, that is, add a and b and divide by 2, we will find another real number. Let's call it c. Now, this c is exactly between a and b. That is, the difference between a and c is the same as c and b. And c is also distinct. Now here is the crazy part. Since c and b are distinct, we will find another real number between c and b by taking the average of c and b. Let's call it d. Then we will find another number between d and b, and so on. In fact, we will find infinitely many numbers between a and b. For 1 and 3, we will find 2 as their midpoint. Then we will find 2.5 between 2 and 3. Then we will find 2.75 between 2.5 and 3, and so on. So there will be infinitely many numbers between 1 and 3. This is known as the density property of real numbers. This states that the real number is infinitely dense. Notice that no matter how small the distance is between two numbers, there always exist infinitely many numbers between them as long as they are not equal.